Hey everybody. So we are getting into chapter 9 today, which basically deals with what are called polynomials. All right. And throughout chapter 9, we're going to be doing, different things to polynomials. In 9.1, today we're going to be adding and subtracting them. All right. But the first thing we're going to do is actually figure out what is a polynomial. All right. So go ahead and get this title, get, a polynomial and all of its different parts here, and then I'll explain what's going on. Okay, so what is a polynomial? Basically, a polynomial is just an expression that has a certain number of terms. All right, well, what are terms? Basically, terms are these little clusters of numbers and variables. An easy way to think about it is a term is anything that's being, glued together by multiplication. Okay, so this 2x cubed is a term, this x squared is a term, this minus 5x is one, this 12 is one. All right, so those are all considered terms. And you can see in this particular polynomial, there's 4 terms. All right, the easiest way to, figure out how many terms you are, terms are always separated by addition or subtraction. All right, so that's kind of the easiest way to think about it. Just look for those plus and minus signs. Those break apart, your different terms. Okay, here are the specific parts of a polynomial. Okay, the first one here is what's called the leading coefficient. Okay, and basically that is the number at the front of your polynomial. Okay, the leading coefficient on this would be a 2. All right. One thing to know though, for you to figure out your leading coefficient, your polynomial needs to be ordered in a certain way. Basically, the term with the greatest exponent needs to go first, and then the next biggest exponent, and then the next one, leading all the way down to this term, which is called the constant term. Okay, the constant is just a term that has no variable attached to it. Basically, it's a number. Okay, the constant on this one is 12. Okay, so the last thing is the degree of a polynomial. Basically, the degree of a polynomial is the biggest exponent that you have. All right, so on this one, the degree of this polynomial would be a 3. Okay, and we'll get into that in a little bit. All right, so yeah, that's what a polynomial is. The next thing we're going to learn is the specific names we can give to different types of polynomials depending on how many terms they have. All right, so let's look at that. Okay, so we have 3 ones we're going to focus on: monomial, binomial, trinomial. Go ahead and get this slide here with the 3 examples, and then I'll show you what's going on. Okay, so this is a pretty simple idea. Basically, a monomial is a polynomial with just one term. Okay, an example of that would be a 3x to the power of 4. This is just a single term. All right, so that's a monomial. Another example of a monomial, just randomly, would be 12. Okay, if we had 12, that would be also a single term, a monomial. Okay, so if you ever see the word monomial, they're just saying, okay, it has one term. Okay, binomial, as you might expect, is a polynomial with 2 terms, right? Our example over here, 2x squared plus 5xy. This is just 2 terms, all right? And if it helps to show you in your notes, there's one of them and there's the other. This thing is considered a binomial, okay? And then the last one, a trinomial, is a polynomial with 3 terms, all right? Over here, an example of that, 4x squared minus x plus 3. This is 1, 2, 3 terms. This would be considered a trinomial. All right, and by the way, if you want to put these little brackets on these, that kind of helps you show what's going on. Okay, so yeah, if you ever see these words, that's all they're talking about. So refer back to this if you kind of forget what those are. Okay, so our first example is going to be asking us to identify the degree and leading coefficient of our polynomial. And we'll also give it a name as well, just because. Okay, so go ahead, copy this. We'll do this together. Okay, so if you guys remember, the degree and the leading coefficient all has to do with basically the very first term of your polynomial. Here's the big thing though. We need to make sure the terms of our polynomial are in the correct order. If you guys remember, we put the term with the biggest, or I guess you can think of it as the highest sum of exponents first, and then the next biggest, and then all the way down to the constant term. So if we're taking a look at our problem, I notice the term with the biggest exponent is not first. We need to rewrite this polynomial. So I'm going to put, and by the way, this minus side is part of this x cubed. So I'm going to put minus x cubed first, and then I'm going to put my next biggest, my term with the next biggest exponent, which by the way, this is technically to a power of 1, right? So that would be a positive 15x, right? This is positive. And then the last thing is this term, which technically is the constant, which is 3. Okay, so now that this thing is in the correct order, now we can identify these things they're asking for. So identify the degree. If you guys remember, the degree is that the biggest exponent that our term has. So let's go ahead and point out that on this one, our degree is 3. By the way, we might want to just do this. Let's do this. Let's just show the degree is this thing, 3. Okay, I think that works better as far as you having, showing it in your notes. Okay, the leading coefficient is the number in front of our polynomial. On this one, you can see it's this minus sign, but remember, there's an invisible 1 there. Okay, so technically, this negative 1 is our leading coefficient. Okay, so let's go ahead and add that. Again, maybe it's easiest just to circle it. So leading coefficient is this thing, our negative 1. Okay, that's all they asked for, but let's point out a couple more things. Let's also point out that this number at the end is the constant. Okay, so, by the way, sometimes you won't have a constant. If this minus 3 wasn't here, if this was just these two terms, I wouldn't have a constant. Sometimes it's there, sometimes it isn't. Okay, the last thing I want to do is let's give this thing a more specific name. I notice it has 3 terms, right? So what is this thing technically called? It's a trinomial, right? So let's go ahead and give it a name. Let's say trinomial. Okay, so we gave a little bit more information than they asked for, but really the big thing I wanted to point out is the order of your polynomial matters. So make sure you get it in the correct order before you start to, give things different names or really do anything. That's the first step you'll always do is if it's out of order, get it in order. Okay, let's look at one more of these. Okay, same directions, but to go ahead and get this problem, I'll show you something a little strange happens on this. Okay, so if you guys notice on this, first of all, I noticed that this looks like it is in the correct order. All right, here's the question. What is the degree of this polynomial? Okay, is it 3? Okay, the answer is no. Okay, because technically the degree of a polynomial is the highest sum of exponents of any one of the terms. Okay, sum of exponents. This is a power of 3. This is a power of 1. Technically, those would give me a 4. All right, so the degree of this polynomial, and I guess we'll just write this separately. Let's use the same colors what I used on the last one. Degree was blue. Okay, so let's point out that the degree of this polynomial, degree is 4. Okay, and if it helps, you can kind of show that it's these two things added together. Okay, and that's really the big thing on this one. The leading coefficient is still this number in the front, so we can still point out this is the leading coefficient. Coefficient. All right, and then it didn't ask us, and we won't do it on this one, but 15 would be my constant. This thing also has 3 terms. It would also be a trinomial. Okay, but the big thing here is if you have multiple variables in a term, you need to add their exponents to figure out what the degree is. Okay, so just something to know. These degree problems, they don't show up very often. It's just a good thing to know. All right, so on the next slide, I want to look at some sort of special cases. Yeah, this is probably worth copying down. These are just some examples, some expressions, and it's asking, is it a polynomial or not? All right, so I think this is worth getting. Go ahead and take a minute and get this. Okay, so here is our expression. On the first one, it's a 9. The question is it a polynomial? Yes, it is. Technically, this is a single term. This is technically a monomial. All right, so that's just something to know. 9 can be considered a polynomial, more specifically a monomial because it has one term. Okay, let's look at the next one. 2x squared plus x minus 5. Is this a polynomial? Yes, okay. Specifically, it has 3 terms, so it would be a trinomial. And by the way, this is a really common type of polynomial. you'll see trinomials with an x squared. These are technically considered quadratics, but we'll get into that in the future. Okay, on this next one, is this considered a polynomial? No. Okay, you might think, oh, but it has two terms. Why, why isn't this a binomial? Because it has a variable in the exponent. Okay, or as an exponent. We cannot have variables as exponents. So if you want to point out, that's the reason why this thing is not a polynomial. That's one of the things we cannot have in polynomials. Okay, next one. Is this a polynomial? It also looks like it has two terms. The answer is no. And the reason why is it has a negative exponent. We cannot have negative exponents in polynomials. Okay, so we cannot have variables as exponents. We cannot have negatives as exponents. Okay, and then the last one here, is this thing considered a polynomial? It has two terms. It looks like our exponents are positives. They're not variables. So yes, this thing is a polynomial. Okay, technically two terms, it would be a binomial. Okay, so just look out. Those are the two ways that something turns into not a polynomial. Okay, we won't see those very often, but it's good to know. Okay, so now to the second part of this lesson. How do we combine or add and subtract polynomials? All right, or rather terms. Okay, so go ahead, get this down, and I'll show you how. Okay, so this is a really simple idea. To be able to combine terms, they must be like terms. They must be considered like terms. Okay, well, when is something a like term? Okay, like terms have to have the same variable and the same exponent. Okay, which is not a bad idea to maybe add into your notes. So same variable and exponent. Okay, so what that means is b squareds can only be combined with b squareds. Okay, not a squareds, not b cubes, only b squareds go with b squareds. And that's what it means to be like terms. It's a really simple idea. When we have that, we can combine them. We can add or subtract them. So I can do a -3 plus 7, which would give me a 4, and then that b squared just kind of tags along and stays. Okay, so yeah, that is combining like terms right there. Okay, so let's keep moving. Okay, let's try another one here. Go ahead and get this example real quick and we'll combine these terms if we can. Okay, so the question is are these like terms? They both have an x and a y, and they are both all to the same power. Technically, it's a bunch of power of ones, all right? But yeah, they are like terms, so we can go ahead and combine them. A 2 minus 5 will give me a -3 xy, and that is that. Okay, so with that in mind, I'm going to have you guys go ahead and try a couple of these. Go ahead and try to combine these terms if possible. Okay, so on number 1, we have a 2x squared and a 4x squared. Are these considered like terms? Yes, they both are, numbers connected to the same variable to the same exponent, so we can go ahead and combine them. A 2 plus 4 is a 6x squared. Okay, taking a look at number 2. Again, are these like terms? They both have an a and a b squared. So yes, okay, they are considered like terms. So we can go ahead and combine them. 2 minus 7, gives me a -5ab squared. Okay, and I just want to point out, what if on this problem, instead of this being a, say this one had an a squared, okay, and this one, stayed the way, would I be able to combine these together? No, they would no longer be considered like terms because this one would have an a squared and this one wouldn't. And this problem right here, we wouldn't be able to do anything as far as like subtracting these. We'd be basically done on these. Okay. All right. So now let's get to the point where we're actually adding and subtracting polynomials together. So get this example here. Okay, so this looks a little kind of weird right here. I guess the way to think about it is it looks like we have a trinomial added with another trinomial. Okay, just to kind of use those words and get your brain in the right spot. Each one of these has 3 terms. That doesn't really matter though. All we're looking for are like terms. Okay, we can combine like terms no matter where they're at. All right. So by the way, when you go to do these, start with your term that has the exponent to the greatest. That has an exponent that's the biggest one. All right. So I'm taking a look and I'm thinking, okay, x squared, that's the biggest exponent I have. And yeah, I have 2 terms that are like terms. a 3x squared, and technically this is a 1x squared. So I can combine those. 3 and 1 gives me a 4x squared. Okay, when you have a lot of terms that you're combining, I highly suggest crossing them out as you combine them, so you you don't mess up, you don't forget anything as you go along. Okay, so moving down the line, I'm now looking at the next exponent to the next biggest, or the next variable to the next biggest exponent, and I see these x's to the power of 1s. Yeah, those are like terms. I can combine them. A 1x and a 4x gives me a positive 5x. Okay, and again, after you combine them, cross them out. Okay, last thing, I notice I have some constants, just some numbers by themselves. I can go ahead and combine these. A negative 6 plus 10, or a 10 minus 6 gives me a positive 4. Okay, when you are, and then also, cross them out. Okay, now we're certain we've combined everything. There's nothing left over, and make sure everything's in the correct order. Make sure you cannot combine anything else accidentally. Yeah, this looks good. These are not like terms, right? I can't combine a 4x squared and a 5x, so I know this is completely simplified. Okay, so let's try one more together, and then I'm going to have you guys try one on your own. Let's do one where we're subtracting a couple polynomials. Get this. Okay, so here's the thing. On the last problem, this plus sign was technically being applied to all three of these terms, but a plus sign does not change the value of anything. It was staying an x squared, a 4x, a 10. Okay, but when there's a subtraction symbol in front of a polynomial, when there's parentheses around it, it needs to be applied to all terms inside. So I need to go one step first, and I need to apply that negative to all of these. This one right here, there's nothing in front. These are not changing, okay? So I'm going to go and just bring these down. 4x squared minus 3x plus 5. By the way, I'm getting rid of the parentheses. I don't really need them since there's nothing in front of them. On this one, I'm going to apply that negative. So a negative 3x squared, a negative double negative becomes a positive x cubed. And again, double negative becomes a positive 8. Okay, so here's all of my terms. Now let's go ahead and start combining what we can. Okay, I'm looking for my variable that has the biggest exponent, and I'm noticing this x to the power of 3, that's my biggest one. So here's the question. Do I have any other x's to the power of 3s that I can combine this thing with? No, I don't. Okay, which is fine, but that needs to still come down as part of our answer. So this x cubed, it's not combining with anything, but that's okay. Let's cross it out. Okay, now let's find the variable to the next big, or the next smallest exponent, and it looks like we have these x squareds we can combine. So a 4x squared minus 3x squared gives me a 1x squared, a positive 1x squared. By the way, instead of writing 1x squared, let's just write it as x squared. Okay, cross them out. Okay, now I'm looking for just x's to the power of 1. It looks like I have that. Do I have any other x's to the power of 1? No. So this minus 3x is just coming down. Okay, cross it out. Last thing, I'm looking at my constants. I have a 5 and an 8. I can combine those together and get a positive 13. Okay, and now I'm just taking another look, and I'm thinking, okay, have I combined everything that I can? Yeah, I'm good. I can tell that because I crossed them out. Do I have any other like terms that I need to combine? Nope, these are all different. So I know this thing is completely simplified. Okay, cool. So I'm gonna have you guys try one of these out. Okay, go ahead and do the same idea with this one. Be careful. We have this minus sign here. You need to take care of that first before you start combining like terms. Okay, give it a try. All right, so this minus sign, again, we need to apply it to every term in the parentheses over here. There's nothing in front of these, so these are staying the same. 5x cubed, positive 4x squared, minus 2x, just bring them down. Okay, but now I can apply these. So this is a negative 4x squared. This is a negative 3x cubed. Double negative gives me a positive 6. All right, now let's go ahead and combine any like terms we might have. All right, I'm taking a look. Biggest exponent I have is a 3, and it looks like, yeah, I have 2x cubes. Okay, 2 terms that have an x cubed, so I can go ahead and combine those. So a 5x cubed minus 3x cubed gives me a 2x cubed. Okay, cross them out. Okay, moving down the line, now I'm looking for any x squareds. Looks like I do have multiple x squareds. Here's the thing. What's a 4x squared minus 4x squared? 0. Okay, they're gone. They eliminate one another. All right, so 4x squared minus 4x squared, they're gone. We don't even need to write the 0. Okay, last one, or I guess the last one with an x, this negative 2x, are there any x's to combine it with? Nope, so I'm just bringing it down. Okay, cross it out. And last thing, I have this constant, 6. Is there any other constants to combine it with? Nope. So just bring it down. And there it is. Okay. And yeah, this is what we're left with. No like terms, so we know it's completely simplified. Okay, so yeah, that's the parts of a polynomial, and that's how you combine like terms. Fundamental stuff when it comes to this chapter and things we're going to be doing in the future. All right, guys, thank you. I'll see you.